So, good day, guys. So, our topic for today in quantity surveying is about concrete. So, there are two types of concrete, plain and reinforced concrete. So, concrete is either plain or reinforced. By definition, plain concrete is an artificial stone as a result of mixing cement, fine aggregates, coarse aggregates, and water. So, meron tayong ano natin, yung plain tsaka reinforced concrete. So, sa tingin ko, lahat naman tayo nakakita na ng reinforced concrete. So, hindi lang kayo sa mga bahay nyo, yun na yung tinatawag nating reinforced. Tingnan yung mga columns, beams natin. So, there are different types of concretes used in construction. So, meron tayong tinatawag na ordinary Portland cement. Ito yung kadalasan na ginagamit natin. Tapos, meron tayong rapid hardening Portland cement, which is preferred when high early strength concrete is desired. The blast furnace or sulfate cement used on concrete structures designed to resist chemical attack. So, meron tayong isa pa, yung low heat Portland cement used for massive sections designed to reduce the heat of hydration. Tapos meron tayong Portland pozzolan cement with a low hardening characteristic concrete, and last is the high alumina cement. So high alumina cement is sometimes called aluminous cement or cement fundu. Its chemical composition is different from that of the Portland cement, for having predominant alumina oxide content of at least 32% by weight. The alumina lime is within limit of 0.85% to 1.3%. So, uh, ito yung type ng cement na mataas yung strength compared sa ordinary Portland cement. Pero, siyempre, pag mas mahal yung natin, yung pag mas mataas yung strength, mas mataas din yung pressure niyan. So, aside from its rapid hardening properties, it can resist chemical attack by sulfate and weak acids, including seawater. It can also withstand prolonged exposure to high temperature of more than 1000 degrees Celsius. So, aluminum cement, however, is not advisable for mixing with any other type of cement. So, there are main composition of cements. 1.6 to 65% lime, 18 to 25% silica, 3 to 8% alumina, 3 to 5% iron oxide, 2 to 5% magnesia, and 1 to 5% sulfur trioxide. So, ito yung main composition ng cement natin. So, pinakamalaking part dun ay ang lime. So, aggregates. So, there are two kinds of aggregates, the coarse and the fine. So, coarse aggregates such as crushed stone, crushed gravel, or natural gravel with particles retained on a 5 mm sieve. So, any particles retained sa 5 mm sieve is classified as coarse aggregate na. So, pag pumas yun sa 5 mm, it is considered as fine aggregate. So, fine aggregates such as crushed stone, crushed gravel, sand, or natural sand with particles passing on a 5 mm sieve. So, 5 mm, pakaliit na nun. So, size of aggregates. For coarse aggregate, the maximum nominal size varies from 40, 20, 14, 10 diameter per mm. So the choice from above size as dimension of the concrete member, more particularly the spacing of the steel bars, reinforcement, or as specified. So good practice demand that the maximum size of aggregate or gravel should not exceed 25% of the minimum thickness of the member structure, nor exceed the clear distance between the reinforcement bars and the front. So, meron tayo dito pang ibang so there are principles in mixing concrete. So, ito yan. First is the workability. Second is the strength. Third is the durability. Fourth is the economy. So, the portion that will be finally adopted in concrete mixing has to be established by actual trial and adjustment processes to attain the desired strength and the quality of concrete required under the following procedures. First is the water cement ratio is determined at the very first hour of mixing to meet the requirements of strength and durability. So, time is of essence kung naghahanap tayo ng semento. So, sabi dito, water cement ratio is first determined at the very first hour of mixing. So, cement aggregate ratio is then chosen and established to satisfy the workability requirements. Workability means the ability of the fresh concrete to fill all the voids between the steel bars and the forms without necessarily exerting much effort in tamping. So, laboratory tests showed that water cement content ratio is the most important consideration in mixing because it determines not only the strength and durability of the concrete but also the workability of the mixture. So, concrete mixtures in a paste form is preferred than those mixtures which are flowing with water. So, ang pinaka-importante natin na i-consider is the water cement ratio. Kasi nga, first natin i-consider is workability. So, it corresponds with pag mas maganda yung water cement ratio natin, mas maganda yung workability ng cement natin. So, meron tayo. Ito yung mga natin pakibasa na yung ACI requirements for concrete natin. So, ito na tinatawag tayong concrete mixture classified as design mixture and prescribed. Tapos, yung design mixture natin is where the contractor is responsible in establishing the mixture proportion that will achieve the required strength and workability as specified in the plan. And prescribed mixture where the designing engineer specify the mixture proportion. The contractor's responsibility is only to provide properly mixed concrete containing the right proportion as prescribed in the plan. So, kadalasan, ang ginagamit natin sa mga construction site is ang prescribed mixture. Kailangan ng computation sa design mixture. So, meron tayong mga unit of measure. Kadalasan na yung nagamit natin is in SI or System International. So, conversion from inches to meter. So, kadalasan, 1 inch natin to. 1 inch is equal to 0.25 meter. So, ito yung accurate natin niya. So, pagdating sa estimate natin ay 0.25 na lang kasi approximate yung gamitin natin. Pakinggan mo. So, ito ay in inches. So, try natin for instance. In solving problems, the probability of committing error is substantially high when 7 digits numbers are being used. Several digits are being used. For example, it is easier to use 0.1 meter, the approximate equivalent of 4 inches, than 0.1016, its exact equivalent, be it multiplication or by division process. So, for example, 8 divided by 0.10 is equal to 80 by inspection analysis. Tapos, 8 over 0.1016 is equal to 78.7 by long process of division. So, to memorize the value of the given table is a waste of time. So, huwag mo yung solving yung table. Not practical in estimating. So, a simple guide will be adapted so that we could easily determine the equivalent values from English to metric or vice versa. Example, to convert meter to feet, divide the length by 0.3. So, say 6 meters divided by 0.3 is equal to 20 feet. To convert feet naman to meters, multiply by 0.3. Say 30 feet times 0.3, 9 meters. So, para mas madali yung conversion natin kaysa sabihin natin 3.28, mga ganon, 0.328. Mas madali natin masasolve yung estimate. Tapos to convert inches to meters, just remember the following volume equivalent. So 1 inch, 2.5 centimeter, 2 inch to 5 centimeter, so on and so forth. So ito guys, gagamitin lang natin to pagdating sa estimate. Pero pag sa pag-solve ng mga, for example, mga engineering problems, ay magiging exact yung ano natin, equivalent. Exact yung gagamitin natin, hindi yung hindi yung ano lang siya. Yung parang ganito lang natin na gagamitin. Hindi yung approximate value lang. Dapat yung gagamitin natin pag may engineering problems is accurate. So dito lang ito gagamitin natin. So may example na tayo. So sa example number 1 dito. What is the meter length equivalent of 7 inches by simple analysis? 7 inches can be the sum of 4 and 3. Therefore, 4 inches is equal to 0.10 meters. Tapos, 3 inches is equal to 0.075 meters. So, answer, 0.17 meter. So, parang ganun na yung pag-ganun natin. So, concrete composition. Proportioning concrete mixture is done by two different ways, by weight and by volume method. The most common and convenient way is the volume method using the empty plastic bag of cement, or by measuring bags for sand and gravel as explained. Measuring the aggregates and water by weight is sometimes using concrete batching plant for ready mix concrete or as specified in the plant. So, makikita nyo naman dito, based dito sa ano natin, sa figure, ang mixture, ang dimension ng box natin is 30 by 30 by 30 centimeters. So, ito yung measuring box natin na tawag. So, meron tayong ano dito, concrete proportion. Meron tayong class AA. Proportion natin is 1 is to 1 half is to 3. So, ibig sabihin nun, 1 cement is equal to 1.5 sand is to 3 gravel. So, kung meron kang isang, for example, meron kang isang bag ng semento, ang halaga nun sa sand is 1.5 bag ng sand. Tapos, 3 bags naman ng gravel. So, parang ganun yung ano natin, proportion natin. So, parang ganito. May 12 by 9.5. Tapos, meron naman tayong tinatawag na 0.5 naman, tapos 1 sa gravel. So, may class mixtures kaya dahil dito. Ito, class mixture. Class AA, class A, class B, class C. So, ito yung ano natin proportion. 1 is to 2 is to 4. Tapos, 9, tapos 7, tapos 1. Ito, ang 9 corresponding sa bag to. Bags. Kung ilang 9 na 40 kilograms na bags. So, for example, meron kayong 90 bags. 90 bags dito. Tapos, times din yung halaga ng weight or volume ng 90 ay ng 9 times 40 kilograms na bags. Tapos, into sand, 0.5 into times ng 0.5. So, yan yung ano natin, proportion natin. So, dito, class A, class B. Sa tingin ko narinig din naman yung class A, class B. So, ito yung proportion natin. Yan. 1 is to 2 is to 1 half is to 5. So, kadalasan natin ginagamit dito is class A. Yan. Class A. So, try na natin mag-solve. So, may example tayo dito. A proposed concrete pavement has a general dimension of 10 cm thick, 3 meters wide, and 5 meters long. Determine the quantity of cement in bags, sand, and gravel in cubic meters required using Class C mixture. So, meron daw tayong slab dito. May 0.10 na thickness. Ito, 0.10. Tapos, may 3 meters na wide tsaka 5 meters na length. So, compute muna natin yung volume. So, paano mag-compute ng volume? So, ano lang, volume is equal to thickness times width times length. So, by volume method tayo. So, 0.1 centimeters. Hindi. 0.1 meters na. So, 0.1 meters times 3 meters times 5 meters. So, volume natin is 1.5 meters. So, kung may 1.5 meters na 1.5 cubic meters na tayo, try natin i-refer doon sa table. So, parang ito. So, ito. Meron tayo dito. Ito. 9.5 tsaka 1. Yun yung ano natin. Yung para sa, hindi. So, type C, class C kasi tayo kaya. So, 6.5 tsaka 1. So, para sa cement, 1.5 cubic meters times 6 is 9 bags. So, pag nag-times tayo ng cubic, itong volume natin, times natin sa 6 na multiplier para sa bags, lalabas is, para sa cement, lalabas is bags. Tapos, yung 1.5 cubic meters, yung multiplier natin na 0.5 cubic meters yung lalabas. So, 0.75 cubic meters. Ang isa naman, para sa gravel, is 1.5 times 1. Kasi 1 yung multiplier natin, is 1.5 cubic meters. So, take note, the computation is for 40 kilograms of cement. Suppose that there is now 40 kilograms cement and what is available are 50 kilograms per bag. How many bags will be ordered using the latter? So sabihin daw natin walang 40 kilogram bags ng cement na available. So, gagamitin natin is 50 kilogram cement. So, nun lang, tingnan natin ulit dun sa table. So, kasi yung ginamit natin is kanina sa type C, sa class C is 66 multiply natin. So, ngayon, kasi wala ang 40, gagamitin natin is 50. So, times 5 yung gagawin natin. So, 1.5 times 5 is 7.5. So, bags. So, sand is 1.5, ganun pa rin. Tapos, ang gravel naman is 1. So, yun yung natin, by volume method. So, etong sinabi ko kanina na proportion na ito, ginagamit natin to para sa by weight. By diba, dalawang natin is by weight at volume method. Dito naman, gagamitin naman na ito by weight to. Ito, gagamitin natin ito by volume. So, proceed naman tayo sa example number 2. A rural road 6 meters wide after base preparation requires concreting of 1 kilometer long. Find the number of bags cement, sand, and gravel required using Class A concrete if the slab is 6 inches thick. So, meron daw tayong 1 kilometrong slab. So, daanan to. So, main road to. So, 1 kilometer. So, meron daw tayong 6 meters na wide. Tapos yung length is 1,000 meters. So, ang thickness o ang kapal ng natin is 6 inches. So, 6 inches times 2.5 ay lang. Yan yung natin. So, 0.15. So, 15 centimeters. So, 15 centimeters. So, convert lang natin into meters. So, divided by 100 lang. So, ito yung ulit. Volume lang ulit. Kung anong volume nito. Volume is equal to thickness times width times length. So, thickness is 0.5 meters. 0.15 meters times 6 meters. Ang width ng natin, road, times the length na 1,000 meters. So, lalabas is volume natin is 900 cubic meters. So, malaki. Kasi nga, 1 kilometro yung ano natin. So, sabi, ang ano daw natin is class A. So, class A. So, ang ano natin is 9.0 times 0.5 tapos 0.5 tapos 1. So, 900 times 9 is 8,100 bugs. So, yan kailangan natin bugs para sa class A. So, 900 naman. 900 times 0.5 is 450 cubic meters. So, 9 times 1 is 900 cubic meters. So, ang kailangan natin total ay sa lahat-lahat is 8,100 bags for cement, 450 cubic meters for sand, and 900 cubic meters for gravel. So, what if there is no available 40 kilograms cement and 50 lang yung available? So, tingnan ulit yung table. Ang multiplier natin para sa 50 for class A cement is 7. So, 900 times 7 is 6,300 bags. So, hindi naman nagbabago yung sa sand at sa gravel, yung multiplier ko kahit anumang class. So, ito yung ano natin for class C. For class A, 50 kilograms of cement. So yan yung ano natin. Ito. Take note, pag mas mataas, for example, take note pag mas madaming nakubit nating bags ng cement, for example, yan. Ito. Kasi ano yan, 50 kilograms yan. Ito naman, 40 kilograms. Kaya mas madami itong 40 kilograms. For example, palagi yung tatandaan na mas maganda ang class, mas mataas ang class, pag mas mataas ang class, mas maganda yung magiging mixture natin, mas magiging matibay yung concrete natin. Kasi nga, mas madaming semento yung nagagamit natin. For example, ito, 900, for example, ito, class A ito, di ba? So, for example, class B yung gagawin natin. Ilan yung multiplier ng class B natin? Class B is 7.5. So, 900 times 7.5 is 6,750 bags lang of cement lang yung for class B. So, isipin nyo, nawala yung halos 1.5, 1.6 na bags ng cement. So, nawala ng bags ng cement is 1,000 plus. 1,350 bags yung nawala. So, isipin nyo, napakaraming semento yung nawala. So, isipin, mas mahina yung magiging concrete natin compared sa class A. So, remember, pag mag-estimate tayo, mas mataas dapat yung class na gagamitin natin para mas malakas yung concrete strength ng concrete. So, meron pa tayong example, a national highway project as shown. Specify 25 centimeters thick concrete. Find the number of bags cement, sand, and gravel required using class A mixture. So, meron daw tayo dito ito. Ang thickness niya daw is 25 centimeters. So, thickness is 25 centimeters. Ito, yung 7.2 meters is ang width. Width. Tapos ito naman, 1,000 meters is ang length. So, convert mo lang yung 25 centimeters into meters. So, divided by 100 lang. So, volume natin ulit is thickness times width times length. Yun na yun. Is equal to 0.25 times 7.2 width times 1,000 meters length. Volume natin is 1,800 cubic meters. So, ulit, ano yung multiplier natin pag Pag sa cement is 9. Pag sand gravel is 0.5 and 1. So, compute lang. Simple calculation lang. 1,800 times 9 is 16,200. Tapos, para naman sa sand is 0.5. So, 900. Kalahati lang ng 1,800. 900 cubic meters. Sa gravel naman is 1,800 cubic meters. So, what if naman daw pag walang 40 kg na available? So, anong multiplier para sa 50 kilograms? So, 7. So, 1,800 times 7 is 12,600 bucks. Huwag kayong magtataka na mas malakas po yung sa 40 kilograms kaysa sa 50 kilograms. Hindi po yung ganun. Kasi, pag ganito, parang mas lumiit lang yung bags kasi nga yung mas lumaki, mas bumigat yung weight ng cement na gagamitin natin. So, ibig sabihin, paras pa rin yung strength or concrete strength ng dalawang yan. Kahit 40 kilograms man or 50 kilograms as long as class A sila. So, meron tayo dito illustration 1-4. The ground floor of a residential house has an area of 200 square meters. So, may area daw ng 200 square meters. The plan specifies 4 inches thick concrete floor on fill using Class C concrete. List down the materials required. So, meron daw tayong ground floor na 200 square meters. So, 200 square meters. Tapos, ang thickness daw is 4 inches. So, 4 inches ang thickness ng slab natin. So, find the volume of the slab. So, paano ba natin hahanapin yung So, convert muna natin yung 4 inches into meter. So, lalabas is 0.1 meters. Convert nyo lang. So, kung area to, area times length, times thickness, magiging volume. So, 200 times 0.1 is 20 cubic meters. So, nakuha nyo na. Simple lang. Cement, Class C. Plug-in tanda. Class C yung gagamitin natin ngayon. So, 40 kilograms. Agad-agad yung gagamitin natin. So, 20 times 6. Multiply sa type sa Class C, 6. So, 120 bags. Sa cement naman, 0.5. Tapos, ito yung makuha natin sagot. Simple lang, diba? So, yan na yung yan. So, meron tayong problem exercise dito. Yung problem exercise natin ay magagawin nating assignment. Assignment natin to. Assignment. Deadline natin to, okay? Friday next week. Friday next week to. Ito ang dalawa. Dadagdagan pa natin yan mamaya. So, tapos na tayo mag-estimate ng concrete slab by volume method. So, mag-estimate naman tayo ng concrete slab by area method. So, estimating concrete slab by the area method is much easier than the volume method as explained. However, this could be done with aid of this table, which readily offers the quantity of cement, sand, and gravel per square meter, depending upon the required thickness of the slab. So, try natin. So, example, solving the problem of illustration 1-1 and 1-2 by area method, we have the following solutions. So, ano daw yung illustration 1-1? Ito po yan. Ito. 1-1. Ito. Illustration 1-1, ito yan. Tapos, illustration 1-2, ito naman yan. Yan. So, by area method, so, hanapin lang natin yung area. So, meron tayong width. Huwag niyo makalimutan yung width kanina is 3 meters, tsaka 5 meters. Yan. So, 3 times 5, 15 square meters. Simple. Tapos, refer tayo sa table for Class C. Class C yung mixture natin. So, yung thickness natin is 10 centimeters. So, 10 centimeters ito. Ito. So, type C, ito yon. Ito, yeah, type C. Point, saan yan Sa 10 centimeters by area method. So, 0.6. Tapos naman, sa gravel, ay sa sand is 0.05. Tapos 0.1 sa gravel. So, saan tayo ulit? Ito na. Ito na yung natin, nakita natin. Yan. 15 times 0.6 is 9 bags. Sand, 15 times 0.05, 0.75 cubic meters. Gravel naman is 15 times 0.1, 1.5 cubic meters. So, check nga natin kung 9.75 tsaka 1.5 ang sagot kanina sa by volume method. So, tama. So, okay yung natin. So, tama yung sagot natin na equal yung volume tsaka by area method natin. So, how about naman sa 1-2? Sa illustration 1-2, yan. 6 by 1 meters, 1,000 meters. So, 6 meters times 1,000 para makuha natin yung area lang. So, punta tayo sa class A. Class A daw. Tapos, 15 centimeters. Tingnan natin yung 15 centimeters. Saan ba yung 15? Ito. Yung 15. So, class A, 1.35 ang ito times natin sa bag, sa cement. Tapos, ang ano naman sa sand is 0.05, 0.075, tsaka 1.50. 1.50 naman para sa gravel. So, puntahan natin ulit. Ito. So, 1,000, 1.35, 0.075, 1.15. So, yung area na nahanap natin, times lang natin sa multipliers nito. Makuha natin yung sagot. So, 1.8 kanina, 1.1, 8.1 bags. Tapos, tama yan. So, 450 cubic meters, tama rin. Tapos, 900 cubic meters sa gravel. So, napansin nyo, always mas malaki yung volume ng sand, ng gravel kaysa sa sand. So, again, comparing the result with the illustration 1-2, the answers are practically the same. Thus, solving the quantity of cement, sand, gravel for concrete pavement and walls can be done with volume method and the area method. Lagi dito, the choice is yours. So, pili na lang kayo kung saan kayo mas comfortable. By volume method or by area method. So, another example tayo. Illustration 1-6. A concrete wall 3 inches thick with general dimensions of 3 meters high. Ito yan. Taas na ng concrete wall natin is 3 meters. Tapos, meron daw tayong 7 meters long. Yan. 7 meters. Tapos, specify class B mixture. Find the number of 40 kg cement, sand, and gravel required. So 3 inches. 3 inches times 2.5 centimeters. Lalabas is 7.5 centimeter. So, hanapin muna natin kung ano magiging multiplier natin 7.5. So, anong class din natin? Class B. So, class B daw tayo. So 7.5. Ito yan. Class B. 40 kg cement. 0.563. Yan. Tapos, multiplier natin sa sand is 0.0375. Tapos sa gravel naman is 0.75. Yan. So, yan yung mga multipliers natin by area method. So, hanapin natin yung area. Kung area method, hanapin natin yung area. So, 3 times 7, 21 square meter. So, na-refer na tayo sa kanina, sa table. Yan. Yung para sa class B, 0.63 ang multiplier para sa cement. Para naman sa sand at sa gravel is 0.375 and 0.75 respectively. So, ito times lang natin yung area natin kanina. So, ito na yung nalabas. So, simple lang. Yan. Tapos, ito, nakalagay dito. 11.82 say 12 bucks. Yan. Ba't natin sinabing say 12 bucks? Simple lang. Kasi wala tayong mabibiling 0.82 bag sa market. Sabi, bili po ng 0.82 bag. Meron po kayong ganun. Wala po. So, pag ano natin ganyan, convert natin, round off natin. For example, 12.4 bags ang na-compute nyo. I-round off nyo na agad. Magiging 12 bags yan. Kasi wala nga tayo mabibiling 0.4 na bags. So, kung 1. Ano man yan, 1.1, automatic. 11.1, automatic. 12 bags na yan. Yung gagamitin natin. So, as long as hindi tayo kumulang sa estimate natin, okay lang sumabra ng konti as long as hindi tayo kumulang. So, yun yung ano natin sa estimate. So, meron tayo ulit ditong problem exercise. Ito, 1, 2. Dagdag po to sa assignment natin. So, due date nito, yung naunang due date nito. Kita mo sa inyo para ma-screenshot na maayos. Yeah. Due date po nito is next week. Due date is next week, Thursday. Next week. Ano ba ngayon? So, 24. Due date is March 24. So, next topic is square concrete column. So, tapos na tayo kanina sa slab. Third naman natin is concrete column. Ano naman natin ngayon is square concrete column. So, there are two ways for solving these 4 columns. By volume method, tsaka by linear meter method. So, example na tayo. Illustration 1-7. A reinforced concrete square column is 5 meters long with a cross-sectional dimension of 16 by 16 inches. Determine the quantity of cement, sand, gravel using Class A concrete. So, first natin gagamitin is by volume method. So, 16 inches daw yung natin. 16 inches. So, times 2.5 lang ulit para maging centimeters is equal to 40 centimeters. So, divided by 100 para maging meters. So, yan na yan. Yung natin. So, since yung natin is by volume method, area, anong area ng, alam mo natin yung area. Area is 0.4 times 0.4 is equal to 0.16 square meter. So, find the volume in the column. So, ang haba daw ng ng column is 5 meters. So, para mahanap natin yung volume, times natin yung area by the length. So, 0.16 times 5 is 0.8 cubic meters. So, yan na yung volume ng natin. Column. So, katulad lang ng kanina, based dun sa table, Class A daw. So, ang multiplier natin ay R Class A. So, 9.5 tsaka 1. So, ito na yung natin. Katulad lang kanina yung natin solution. Iba na yung pag-ano natin. So, dito, nakita nyo, 7.2. Ito, say 8 bags. Kasi nga, wala tayong bibiling 0.2 bags sa market. So, round off agad natin. Ito, nag-say lang siya ng 0.4 tsaka 0.8 pang lang to, kasi nga yung estimate natin is hindi perfect ito. So baka magkulang, baka sobra. So as long as hindi kumulang yung natin, yung estimate natin, okay na okay yan. So sinayin niya lang para mas madali, kasi mas ang bintahan kasi ng natin, sand tsaka gravel is per cubic meter. So mas madaling bumili ng 1 cubic meter kaysa sa 0.8 cubic meter. Ito, kalahati ng 1 cubic meter is 0.5. So, mas madaling bumili nun. So, Ito na. So, next problem tayo. Concrete column, 7 meters high, with the cross-sectional dimensions of 20 by 20 inches. Determine the quantity of cement, sand, gravel content in the column. There are 8 columns in the row using class A concrete. So, ito daw yung ano natin, concrete column. So, ito, 20 by 20, 20 inches. Kung makita, ito pala nasasabi. Kung makikita kayong ganito, for example, 20 yan, 20 yan. Ibig sabihin yan, 20 feet. Kung nakita kayong dalawang parang apostrophe na ganyan, yan, ganyan. Ganyan or ganyan. Yan. Ibig sabihin yan, 20 inches. Kasi, mas mahirap na magsulat ng mga. So, kung ganyan, ano yan? 40 feet. So, pag ganito naman, 40 inches. So, yan yung kadalasan makikita natin sa estimate. So, ito yung dimension niya, 20 inches. So, convert lang natin ulit ang 20 inches into meters. So, simple lang, times 0.25. Tama. So, times 0.25 lang. Solve the volume, the square column. So, then, 0.5 by 0.5 times 7 meters. Kasi 7 meters yung taas ng column natin. So, parang prism lang yan. Parang ganito lang yan. Rectangular lang. So, find the volume. Kasi nga, yan. Itong na-compute yung 1.75 cubic meter is 1 column pa lang. Yan. Column. Inulit ko yung na-compute yung 1.75 cubic meter is for 1 column only. So, ilan bang columns natin? 1, 2, 3, 4, 5, 6, 7, 8. So, ita-times nyo ba by 8? So, 1.75 times 8 is equal to 14 cubic meters. So, yan yung volume ng lahat ng 8 columns natin. Ito, 1, 2, 3, 4, 5, hanggang 8. So, refer tayo ulit sa table natin kanina, class 8 daw. So, ito ulit yung multiplier natin for class A. So, 14 times 9, 128 bags. Sand is 0.5, 7 cubic meters. Tapos, para naman sa gravel is 14 cubic meters. So, yan na yung natin by volume method for square concrete. How about naman sa linear meter method? So, ito yung natin. So, kanina, sa area method, nag-refer tayo sa table. Ngayon naman, mag-refer tayo ulit sa table, isa pang table para sa linear meter method. So, yung lang, katulad ng kanina ito. So, ito naman, solving the problem of illustration 1-8, figure 1-12, where 8 columns, yung kanina lang. So, ang first step natin is find the total length of 8 columns. So, meron tayong 8 columns. Yan, 8 columns. Ano yung height niya? So, ang height nila is 7 meters. So, 7 meters times 8 is equals to 56 meters. So, ito yung total length ng lahat ng column. Total length yan, kaya nga So, refer natin ulit tayo doon sa table. Ito, yung size. Huwag niyo kalimutan yung size. Ito, size. Ang size daw ng natin, ang column is 50 by 50 centimeters. Ito. 50 by 50 centimeters. 0.5 meters lang dyan. So, tingnan natin saan dito yung 50 by 50 centimeters. In centimeters yung size natin dito. So, 50 by 50. So, ito yung 50 by 50 centimeters. So, ano daw tayo? Plus 8. So, ulit yung natin. 0.5. So, plus 8. So, tingnan natin. Class A daw. Class A for 40 grams. 40 kilograms. So, sand and gravel. So, Class A, 40 kilograms. Multiplier natin is 2.25. Sand is 0.125 and rubble is 0.5. So, ito. So, tama yung ano natin. Ito. So, yan yung multiplier natin. Multiply natin itong 56 meters times 2.25 is equal to 126 bucks. Para naman sa sand, 0.125, 56 is equal to 7 cubic meters. So, 56 times 0.25 is equal to 14 cubic meters. Yan. So, check natin yun. Yung tama. So, 1, 2, 6, 7, 40. So, tama yung ano natin na by linear meter tsaka by volume meter. So, meron tayong ulit dito ang assignment. Ito, problem exercise. Another assignment po ito. So, ito ay 6. Ito, 6 yan. 6 by 13 meters. Ito ay by 8 columns by 16 meters. Ito ay 10 inches, 20 inches, 22 inches, tapos by 8 inches to. Tapos ito naman ay 24 inches, 12 inches, 10 inches, tapos another 10 inches ng cross section. So, ito yung naman assignment. Assignment naman natin to is next week. Next week to kailan ba yung next week? Tingnan natin. Next week, 31. So, deadline naman nito is March 31. Yan. Para may mga tayo, may gagawin tayo. So, proceed na tayo. So, pose and footing naman tayo ngayon. So, tapos na tayo sa column, tapos na tayo sa slab. So, para naman tayo sa pose and footing. So, structurally, pose is always supported by slab, called footing or foundation. Estimating the quantity of materials for these types of structures could be done by volume method or the area and linear method combined for pose footing or pose and footing. So, example tayo. Concrete pose, 4 meters high with cross-sectional dimensions of 40 centimeters by 40 centimeters is supported by a footing slab 20 cm thick by 1.2 square meter. Using Class A concrete, find the quantity of cement, sand, gravel if there are 12 posts of the same size. So, meron daw tayong 12 posts of the same size. Huwag yung kakalimutan. So, pag may 12 posts tayo na same size, so meron din tayong 12 footings of the same size. Alam mo naman, yung isa lang yung meron, tapos yung 11 na natitira, wala. So, ito yung ano natin. So, ang height ng ano natin is 4 meters. 4 meters. Yan, 4 meters to. Tapos po ay 20 meters and 1.2 meters. So, yan yung cross-sectional. Top dito. So, first step, may volume method. So, unang gagawin natin is find the volume of the 12 posts. So, the volume is equal to sectional area times the height times the number of posts. So, volume, simple lang. 12 posts times yung cross-sectional area. 0.4 times 0.4 times 4 meters. Kasi ito yung 4 meters natin. Yan. Yan yung height ng post natin. 4 meters. So, post muna yung solve natin. So, 7.68 cubic meters. Yan yung volume for post only. For post only. Post pa lang yan. So, how about naman sa slab? So, kung 12 yung post natin, 12 rin yung slabs natin. So, ano yung ng slab natin? Tingnan natin ulit. So, yung slab daw natin is 1.2 meters times 1.2 meters times 0.2 meters. Yan yung thickness ng slab natin. So, volume is equal to 12 times 0.2 times 1.2 times 1.2. So, ang ano natin, 3.456 cubic meters. This is for slab only. For slab lang yan. So, hanapin natin yung total volume. So, total volume is equal to volume of posts plus volume of slabs. So, 7.68 posts plus 3.456 for slab. So, volume total is 11.136 cubic meters. So, refer tayo ulit dun sa table na natin kanina. So, class A daw. So, class A, parang natin nakikita to, 9.5 tsaka 1. So, cement, 11.136 times 9 is equal to 100.2 bags. So, hindi ito nalagay na say. So, ilalagay natin say 101 bags. Tapos dito naman, 11.136 times 0.5 is 5.56 cubic meters. Tapos 11.136 times 1 is 11.136 cubic meters. So, yan yung natin for volume method. So, next solution natin is by linear method and area method. So, itong linear method, ginamit natin to for columns. Yan. For columns yan. Ito namang area method, ginamit natin ito for slabs. Yan. So, kaya combination siya ng linear method, linear meter, tsaka ng area method. Kasi, yung post at saka slab natin is column tsaka slabs lang. Yung post tsaka footing is column and slab, parang slabs rin. So, gawin natin ulit. For post muna tayo. Yeah, ito muna tayo. Find the total length of the 12 posts. Kasi linear meter tayo. So, length is equal to 12 posts times 4 meters. So, ito, nakalagay naman dun kanina sa drawing natin na 4 meters yung height. So, on total length ng 12 posts is 48 meters. So, refer tayo ulit doon sa table. Ito, table 1-4, yung sa linear meter kanina, along 4 centimeters by 40 centimeters by 40 centimeters. Tingnan natin ulit para sa So, 40 centimeters daw. So, ito, class A. So, class A daw yung natin. So, ito yan. Ito lang yan. Class A. Class A po ito. Para makita na iba. 40 kilograms class A. Tapos, ito naman natin, multiplier naman natin para sa sand and gravel. 0.08 and 1.16. So, punta tayo ulit dun sa solution natin. So, tama. So, 1.44, 0.08, and 0.16. So, ulit, ito lang yun. Para sa post lang po ito. Para sa post pa lang yan. Wala pang slab dyan. So, 48 times 1.44 is 69.12 bags. Huwag muna natin isi-say. Mamaya na, pag na-combine na natin yung dalawa. So, sa sand naman is 48 times 0.08, 3.84 cubic meters. Gravel naman is 48 times 0.16 is 7.68 cubic meters. So, para pa lang po yan sa post. Yan. So, paano naman yung para sa slab? So, area method para sa slab, area is equal to 12 pieces kasi nga 12 yung slabs natin, times 1.2 times 1.2. Ito po yung dimension ng slab natin. So, sagot natin is 17.28 square meters. So, punta tayo ulit doon sa refer to table 1-3. Tapos, siyempre, yung thickness ng slab natin is 20 centimeters. So, tingnan natin ulit kung tama ba yung magiging natin. Pag tinignan natin yung table. Ito yung table Ito ulit yung table natin. So, 20 centimeters. So, 1.8, 0.1, tsaka 0.2. So, tingnan natin, 1.8, 0.1, tsaka 0.2. So, ito. So, tama yung ano natin. At pagtingin natin sa table. 1.8, 0.1, 0.2. So, yung cement, yung area na na-compute natin dito, times lang natin sa multiplier. Ang multiplier, 17.28, 1.8, 31.1. So, 17.28, 0.1, 1.22, 1.28, yan. So, on so forth. So, yan na. Ito naman ay para lang sa slab lang to. Slab only. Ito, slab rin. Slab rin to. So, syempre, ito total natin yun. Kasi nga, meron tayo, ito ay post at saka footing. So, ito yung para sa post. Ito naman yung para sa footing. So, combine lang natin. Yung ipa-plus mo sa cement rin. Hindi naman pwede na ipa-plus mo sa cement isa. So, cement para sa post. Tapos cement para sa slab. Sand para sa post, sand para sa slab, gravel para sa post, gravel para sa sand. So, ito na yung natin. So, yeah. So, parehas yung na-compute natin kanina by volume method to linear meter plus area method. So, say natin na 101 max. So, diba madali lang? As long as ang ano lang dito sa linear method, dapat may table kayo. Pero pagdating sa volume at kahit hindi sa ulo yung table, makakomplete nyo. Hindi siya dependent sa table. So, ano tayo ulit? Next problem naman tayo. Illustration 1-11. From the figure 1-15, determine the number of 40 kg cement, sand, and gravel required using Class A concrete for the footing and Class C naman para sa concrete for the flooring 4 inches thick. So, dito, magkaiba yung class para sa Class A concrete for footing. For footing daw, so, magkaiba daw yung class ng ano natin, concrete sa footing tsaka sa flooring. So, ito po yung ano natin, floor. Ito yan. Ito yung floor natin. Tapos ito naman yung floor, ano natin, footing. So, magkaiba sila. So, footing slab muna yung kapitin natin. So, yung footing slab, ito, square lang yung ano natin, yung slab natin. Dito. 0.8, 0.8. Hindi siya pinakita dito sa problem. Kaya, alam niyo na agad na 0.8 to. Ano yan? Square. So, ang thickness is 0.15. So, ilan ba yan? 1, 2, 3, 4. 4 na posts. So, 4 na slabs. So, volume is equal to 0.15 meters times 0.8 times 0.8 is equal to 0.96 cubic meter. So, total volume of 4 pieces footing slab is times 4 lang natin is 0.384. So, meron pa tayong para sa pedestal. Natawag natin pedestal yan pag lesser than, pag mas maliit lang yung column natin. Ito po yung pedestal natin. Ito. Column rin tawag natin. Yan. Yeah. Pedestal ang tawag dyan. So, yung pedestal natin is 0.9. 0.9 ang taas. So, ito. Yung ito, 0.9 yan. Ito yan. Tapos, ito yung pedestal natin Pedestal natin. Baka malito kayo. 0.9 ang taas yan. Tapos, ito, kasi square column lang yan, 0.3. So, compute lang natin. Dito. Volume para sa pedestal is 0.3 times 0.9 kasi 0.9 height, 0.3 cross-sectional area. So, 0.81 cubic meters times 4 pieces. 4 pieces kasi makikita natin dito is 1, 2, 3, 4. So, ito na yung ano natin. Sagot natin. 0.81 cubic meters times 4 is equal to 0.324 cubic meter. So, ang total volume ng pedestal plus ng footing slab is 0.708 cubic meters. So, sabi daw dito, the Class A concrete for footing. So, Class A daw yung footing natin. So, ito na yung ano natin. 0.708, 9.51. So, yun na yan. Tapos, pag nag-anong tayo yan, say, 7 bags. Tapos, yan na yung ano natin. So, madali lang, di ba? So, sir, tanong, ba't po na sama yung pedestal natin sa Class A? Kasi, sabi ba kanina, yung post natin, tsaka ang footing, is para iisa lang yung pag-solve niya. So, ang ano natin is Class A. Kasama na sa pag-categorize ang pedestal as sa footing. So, Class A silang dalawa. So, next natin is ang concrete floor slab. Tingnan natin ulit yung floor slab. So, 4 meters by 3 meters. Tapos, ang thickness niya is 4 inches. 4 inches yung thickness. So, ito lang. 4 inches times 2.5 para maging centimeter. So, centimeter divided by 100 at 10 centimeter divided by 100 is 0.1. So, volume is 0.1 times 3 times 4. So, volume is 1.2 cubic meters. So, type C, Class C, so ito yung multiplier natin. Yeah, 6.5 tsaka 1. So, ano lang natin, combine lang natin. Yeah. So, meron na tayong 7.2 bags, 0.6 cubic meter, 1.2 cubic meter. So, yun na. Ulit, isasama lang natin. Ito. Yung para sa cement, para sa post, tsaka sa footing, ito yon. Itong linya na to, itong column na to. Tapos ito naman yung para sa floor slab natin. Yan. Yan yung. So, ang sagot natin is 14 bags, 0.95 cubic meters, tsaka 1.9 cubic meters. May comment dito. The meticulous estimator, the area occupied by the post will be subtracted from the gross area of the floor, although the result is insignificant amount. Sabi daw, dito, para sa mga meticulousong estimator, yung area daw nito, ang apat na to, minus pa nila sa area ng slab. Kasi meticulousong sila. Pero sa atin, pwede nyo hindi na i-minus kasi nakalagay naman doon is insignificant. Masyadong maliit lang naman yung pagkakaiba. Masyadong maliit lang naman yun kasi ilang naman yung 0.3 by 0.3. So, masyadong maliit lang yan compared mo sa total area. So, nasa sa inyo yan kung gusto nyo ibawas, kung gusto nyo hindi ibawas. So, kasi nga, estimate na yung ginagawa natin. So, estimate word. So, hindi siya exact. So, proceed na tayo sa rectangular column. So, the procedure in estimating rectangular column is practically the same as that of the square column. It could be either by volume method or by the linear meter method as previously explained. The choice of method, however, depends upon the convenience and preference of the estimator. So, yung pag-solve ng rectangular column is halos magkaparas lang sa square column. So, kung parang kanila ito, 40 by 60, tapos 5 meters, try natin. So, ito, find the total length of the columns. The columns, ang length daw is 5 meters times 8, 42 meters. Tapos, refer tayo ulit sa table ng 1-4. Kasi, ito lang naman yun ulit. 1-4. Ito yan. So, ito, kita nyo to. 15 by 20. So, rectangular yan. 15 by 25, rectangular rin. 15 by 30, rectangular. 15 by 35, rectangular. So, Itong table na to is for rectangular and square columns. So, kung paano natin nasolve yung square columns kanina, ganoon tayo mag-solve ng rectangular columns. So, balik na natin tayo sa problem. So, proceed na tayo sa rectangular beam and girder. So, a beam is defined as a strong horizontal piece of reinforced concrete for spanning and supporting weights. On the other hand, a beam that is carrying or supporting another beam is called girder. Similarly, estimating the materials for these types of structures is either by the volume or the linear meter method. So, example na tayo sa figure 1-17, may dalawa tayong isang beam, isang girder. So, pag tinawag natin girder, ito yung sumusuporta rin sa beams. So, ito yung girder natin. Tapos, ito yung beams natin. Yung beams natin ay nakapatong sa girder natin. So, basic example, ang cross-section beam natin is 25 centimeters by 40 centimeters and 40 centimeters by 60 centimeters ang girder naman. So, by volume method, so, find the volume of the beam muna. So, beam muna tayo. So, volume is equal to the number of beams times the thickness, the width of the beam times the thickness of the beam times the length of the beam. So, check muna natin. So, 5 pieces lang. So, 1. So, ginawin natin. 1, 2, 3, 4, 5. So, tama. 5 pieces yung beams. So, times 0.25 times 40. Kasi, in meters na. So, 25 by 40. Tapos, ang span is 8 meters. Dito. Ito na yung 8 meters. So, volume ng beam is 4 cubic meters. So naman is solve for the volume of the girder. So, volume is equal to yung yung volume natin for the girder is 2 pieces times 0.4 times 0.6 times 16 meters. But 16 meters? Kasi yung ito yung girders natin, 16 meters. So, times 2 ito. Tapos yung cross-section is 40 by 60. So, 40 centimeters by 60 centimeters. Lang natin, 2 meters. Lang 2 meters. So, ang volume natin is 7.68 cubic meter. So, after that, kunin natin yung total volume ng beam plus ng girder. So, 4 plus 7.68. Ang volume natin is 11.88. So, ang volume natin is 11.88 cubic meters. So, ito na yung total volume natin. So, class A. So, ang katapusan is 9.5 tsaka 9.5 at tsaka 1. So, times lang natin ulit para sa naman dati. Yun yung makukuha natin. Tapos, yung sa bugs, say natin is 106 bugs. So, ito na yung sagot natin. So, by linear meter method naman, sa beams muna tayo. So, 5 pieces times 8 meters, 5 pieces na beams. So, 40 meters. So, tingnan ulit natin sa table 1-4. Ito yung makikita nating multipliers. So, 0.9 sa cement, 0.05 sa sand, tsaka 0.1 sa gravel. So, times lang natin. Ito na yung makukuha natin. Yan. So, after that, punta naman tayo sa girder. So, sa girder, 18 meters times 2, 32 meters. So, hanapin ulit natin sa table. Table 1-4. Tapos, size is 40 by 60 centimeters. So, class A. Class A. So, ito yung multiplier na nakita natin. So, 2.16, 0.12, 0.24. So, times lang natin yung 32 meters dito sa multipliers natin. Nakita natin to. Yeah. So, yung nakuha natin na result para sa beams at sa girders ay ipa-plus lang natin. So, ito yung para sa beams. Ito naman para sa girder. So, 105.12 paras lang sa volume method. So, 5.84 tsaka 11.68. So, proceed naman tayo sa circular column. So, estimating the materials for circular column is typically the same as the volume method for the square and rectangular column with aid of Table 1-2. However, Table 1.1-5 was also prepared for circular column problems to avail the linear meter method of estimating. So, example na tayo. A circular concrete column has a diameter of 60 centimeters by 8 meters high. Find the concrete materials required if there are 5 columns of the same size in a row. So, solve the cross-sectional area of the, column. By volume method tayo. So, naman tayo na volume is equals to pi r squared h. Pero, ito lang yung area muna natin hahanapin. So, pwede namang direct yan kung gusto nyo. Pero, dito, hiwalay mo na yung area at yung height. So, meron tayong pi r squared or pi d squared over 4. Kung saan ang gusto nyo. So, r, pi r squared area. So, direct substitution na yung 60. Nilagay na agad dito. Sorry, ang 30. 60 divided by 2 is 30. So, radius is 30. So, yun na yung natin dito. Ito. Ang ginawa kasi is ito kasi para to sa diameter. Ito naman para sa radius. So, ang nalagay dito is in diameter. So, pwede rin in radius para sa lang nilalabas. So, ang pi over 4. Ang lalabas sa pi over 4. So, ang sagot natin is 0.283 square meters. So, after that, hanapin natin yung volume. So, volume is equal to 0.283 times 6. Kasi 6 meters yung height. So, 1.698 cubic meters. So, volume total is 1.68998 times 5. Kasi nga, 5 yung column. 1, 2, 3, 4, 5. So, 8.49 cubic meter. So, ito na yung natin. 8.49. So, tayo? Class A tayo. So, ito ulit yung gagamitin natin. 9.5 1. So, 76.4 times lang ulit natin to. Yung cubic times lang. Kung gano'n lang pag-solve natin dati. So, 76.4 bags, say 77, 4.24 cubic meter, 8.49. So, yun na yun. So, yun yung natin, sagot natin. So, by linear method naman, ulit lang, by linear, so, length yung pag-uusapan natin. So, 5 times 6 meters. 5 pieces. 1, 2, 3, 4, 5 na column. So, 30 meters. So, ang natin is 60 cm ang diameter natin. So, class A, tingnan natin dito. So, based dito sa natin, sa table natin, ang natin is 60. So, yan, 60 centimeters. In centimeters to. So, A is 2.545. So, sand is 0.414 and gravel is 0.282. So, tama yung natin. Yan. Yan. Kung nakuha mo na yung multiplier, yun na yung natin, ita-times natin. So, yan na natin. So, parehas lang. Yan. 76.4, 4.23, tsaka 8.46. So, yan na yung natin. para sa circular column. Madali lang. As long as alam niyo paano kumuha ng volume ng cylinder. Kasi ano lang naman cylinder. So, para naman sa problem exercise, ito yung magiging assignment natin. Assignment natin na due March 31. Ito. Kasunod to. Magkasama sila ng last time. Yung sa ito. March 31 to. March 31. Yung isa, March, ano nga yung isa? March 24. Ito naman, March 31. So, mababa yung oras nyo para mag-solve. So, please pass in time para maano natin. So, next na topic natin is masonry naman. So, ito na yung natin. So, deadline nito, padugtong to March 31 deadline. So, padugtong to, ito yung part 2 ng sa nauna kanina. So, next topic is masonry.